The ocean is vast, covering over 70% of our planet's surface. Yet, astonishingly, about 80% of it remains unexplored. The deep ocean, also known as the abyssal zone, stretches from around 3,000 meters to depths of over 11,000 meters. It is a realm of darkness, extreme pressure, and temperatures that hover just above freezing. This chapter begins our expedition into the abyss, where the first vital discovery comes from a recent expedition led by the Ocean Exploration Cooperative Institute. Here, researchers uncovered giant squids, creatures once relegated to the pages of myth. When scientists first captured footage of the elusive Architeuthis ducks, it redefined our understanding of these deep-sea dwellers and marked a pivotal moment in ocean exploration. Giant squids can grow up to 43 feet long and have eyes the size of basketballs, adaptations that help them navigate the darkness of the deep. Analyzing their biology revealed insights into how life can thrive under such intense conditions. Not only do they hunt at incredible depths, but they also possess the ability to communicate through bioluminescence, a method previously thought exclusive to jellyfish and certain types of fish. But what other secrets lie in these depths? Researchers are also discovering entirely new ecosystems in the deep ocean. Hydrothermal vents, for example, offer a glimpse into life systems that exist independently of sunlight. These vents, located on the ocean floor, spew mineral-rich water, supporting diverse life, including tube worms and unique microbial communities. The findings challenge long-held beliefs about the necessity of sunlight for life and suggest that life may exist in extreme environments throughout the universe. As we delve deeper into the ocean, we find astonishing bioluminescent creatures that paint an otherworldly picture in the depths. These organisms use light not only for communication but also for hunting and defense against predators. Imagine schools of jellyfish radiating eerie blue light in the darkness, creating a spectacle that leaves scientists and spectators alike in awe. Each creature we discover adds another layer to our understanding of the ocean's biodiversity. The journey unveils a complex web of life, flourishing despite the harsh conditions. The abyss is not just a graveyard of shipwrecks and lost treasures, it is a vibrant ecosystem teeming with unique life forms. But as we continue our exploration, we must confront a harsh reality: our oceans are under threat, and every discovery we make is a reminder that time is running out to protect these vital ecosystems. Life in the deep ocean is unlike anything we've encountered on land. The adaptations necessary to survive in this hostile environment are remarkable and often defy our expectations. Imagine creatures that can withstand over 1,000 times the pressure we feel at sea level. How do they do it? Among these extraordinary beings is the amphipod, a small crustacean that has garnered attention for its resilience. A recent study revealed a species called Halocephalobus magidi, which was discovered at a depth of approximately 10,000 meters in the Mariana Trench. Interestingly, researchers measured its resilience under extreme conditions and found that it could survive pressures up to 8 tons per square inch. How can such a creature withstand these forces? The secret lies in its unique cellular structure. Amphipods have flexible cell membranes and specialized proteins that protect their internal structures. This adaptability gives scientists insight into potential applications in fields like medicine and material science. But the discoveries don't stop with amphipods. The deep ocean is home to extremophiles, microbes that thrive in conditions that would be lethal to most life forms. These include bacteria that metabolize sulfur, thriving near hydrothermal vents, colonizing rocks, and even surviving in acidic conditions. Their existence raises profound questions about the possibilities of life beyond Earth. As we continue our exploration, we learn about the mysterious giant sea cucumber, which plays an essential role in the ocean's ecosystem by recycling nutrients. These creatures can reach lengths of nearly 3 feet and are equipped with a unique defense mechanism. When threatened, they expel their internal organs to deter predators, a process known as autotomy. In a shocking twist, some of these sea cucumbers have been found at depths where they live in symbiosis with a variety of unusual organisms, creating a mini ecosystem within their bodies. These interactions illuminate the complexity and interdependence of deep-sea life. Whether it's the vibrant coral reefs that thrive around seamounts or the bizarre-looking anglerfish that lure prey with bioluminescent lures, the deep ocean challenges everything we thought we knew about life. Each new discovery pushes the boundaries of biology and reveals the intricate dance of survival that takes place beneath the waves. As we uncover more about these adaptations, we are reminded of the fragility of these ecosystems. Human activity, such as deep-sea mining and pollution, poses significant threats to these communities. Each discovery we make must come with the responsibility to protect these wonders. Without action, we risk losing the astonishing revelations of the deep forever. What allows us to explore the mysteries of the deep oceans? The answer lies in cutting-edge technology that is transforming how we study and understand our planet's depths. From remotely operated vehicles to advanced sonar systems, these tools open up the abyss for exploration like never before. One notable breakthrough is the development of autonomous underwater vehicles, AUVs. These robotic marvels can dive deep into the ocean, gathering data and capturing imagery that would be impossible for human divers to achieve. An excellent example is the AUV called Nereid Under Ice, which ventured beneath Arctic ice to map the seafloor. Its findings have been instrumental in understanding how climate change affects polar ecosystems. But AUVs are just part of the story. The deep-sea submersible Alvin has been a game-changer for oceanographic research since its launch in 1964. Alvin allows scientists to descend to depths of 4,500 meters, bringing them face-to-face with the wonders of the deep. Not only did Alvin play a pivotal role in the discovery of hydrothermal vents, but it has also facilitated explorations for nearly 50 years, contributing to our understanding of marine biology, geology, and even archaeology. One of its most striking missions was investigating the Titanic wreckage, where scientists gleaned insights about decay and preservation in extreme conditions. What makes Alvin particularly special is its ability to collect samples. Equipped with mechanical arms, it can grab sediment and organisms from the ocean floor, allowing for laboratory analysis that leads to further scientific revelations. Additionally, sonar technology plays a crucial role in deep-sea mapping, revealing the ocean floor's complex topography. Multi-beam sonar systems can create highly detailed maps of underwater features, exposing previously unknown seamounts and trenches. This understanding is vital, as it helps us comprehend not only the geography of the ocean but also the habitats that exist there. The integration of satellite technology with oceanographic research adds another layer of depth. Satellites can help scientists observe surface temperatures and chlorophyll levels, providing context for the data gathered from below. Together, these technologies form a tapestry of understanding that paints a clearer picture of our oceans. However, the ultimate challenge remains: how do we protect these fragile ecosystems? As expeditions become more frequent, the potential for human impact increases. The technology that opens doors to discovery must also be wielded with care, ensuring the ocean's treasures are preserved for future generations. As we harness technology to explore, we must remain vigilant stewards of our oceans, ready to face the dual challenge of discovery and conservation. Every species in the ocean plays a pivotal role in maintaining the balance of the ecosystem. As we delve into the depths, it becomes increasingly clear that the discoveries made there hold paramount significance for our planet's health. Take, for example, the keystone species known as the deep-sea coral. These corals provide essential habitats for diverse marine life, fostering biodiversity in the depths. Coral reefs are often referred to as the rainforests of the sea because they support numerous species and are vital to the health of the entire ocean ecosystem. However, the threats facing these corals, from climate change to ocean acidification, are alarming. Scientists have observed widespread coral bleaching and habitat destruction due to human activity. Understanding these impacts is crucial to developing effective conservation strategies. Research shows that ocean currents play a critical role in transporting nutrients across large distances. The deep ocean acts as a conveyor belt, moving these nutrients to support life in shallower waters. They provide the basis of the marine food web, sustaining everything from microscopic phytoplankton to the largest whales. The mysteries of the deep ocean extend beyond its residents. They also inform our understanding of global climate systems. Recent studies indicate that the deep ocean absorbs a large portion of the CO2 emissions generated by human activity. This natural process helps mitigate climate change but poses risks as the ocean's chemistry alters, leading to potentially catastrophic outcomes. What does this mean for future generations? Our deep ocean discoveries are not merely scientific curiosities, they are essential for protecting our planet's future. The knowledge gained from understanding these ecosystems informs policy, conservation efforts, and sustainability practices. By studying deep-sea life, we cultivate a foundation of knowledge that can guide actions for healthier oceans and planet. In a world increasingly affected by climate change, the urgency to protect these ecosystems has never been greater. The deep sea may seem remote and disconnected from our daily lives, but the interdependence of life on this planet is profound. Every small action we take today can have a ripple effect that resonates throughout the complex web of life, reminding us that we are part of something much more significant. As our journey through the deep ocean continues, we must remind ourselves of our responsibility to safeguard its wonders for future generations to discover. What will the next chapter in the story of the ocean reveal? As we uncover the astonishing secrets of the deep ocean, we must also confront the harsh realities threatening these incredible ecosystems. From climate change to pollution, human activity is leaving an indelible mark on the oceans, and the consequences could be dire. One glaring example is the increasing temperature of ocean waters. Research indicates that ocean temperatures are rising at an alarming rate, leading to disruptive changes in marine habitats. Coral reefs are experiencing unprecedented bleaching events, which have devastating effects on entire marine ecosystems. The UN reports that up to 90% of coral reefs could be gone by 2050 if current trends continue. Overfishing is another critical concern. As demand for seafood increases, many fish species are pushed to the brink of extinction. The collapse of fish stocks not only threatens marine biodiversity but also the livelihoods of millions of people who depend on these resources. Pollution is rampant in our oceans, with plastics being the most visible offender. Every year, millions of tons of plastic waste enter the ocean, endangering marine life. From entanglement to ingestion, the effects on marine species are catastrophic. Take, for instance, marine turtles that mistake plastic bags for jellyfish, a critical food source. This misidentification can lead to intestinal blockages and death. But the threats extend beyond visible pollution. The rise of ocean acidification threatens the very foundation of marine life. As CO2 levels rise, oceans absorb more carbon dioxide, leading to harmful chemical changes. This acidification impacts shellfish and coral, which rely on calcium carbonate to build their shells and structures. The implications for the entire food chain are staggering. Furthermore, deep-sea mining for precious metals and minerals poses significant risks. Companies are increasingly looking towards the ocean floor to harvest resources, but the destruction of these habitats can disrupt ecosystems that have persisted for millennia. With every scoop taken from the ocean floor, we risk losing irreplaceable biodiversity. The situation may appear bleak, but there is hope. Grassroots movements and international collaborations are emerging to advocate for the protection of our oceans. Policies are changing, and awareness is growing. Organizations like the Ocean Conservancy and the World Wildlife Fund are leading the charge to protect marine ecosystems. The fight to preserve our oceans is not just about saving beautiful landscapes, it's about ensuring a healthy planet for future generations. As we continue to explore the deep ocean, we must commit to understanding its wonders while fighting for its survival. The journey of discovery is intertwined with the responsibility of stewardship. What will you do to become a guardian of our oceans? As we plunge deeper into the murky depths of Earth's oceans, we uncover the staggering diversity of life forms that have adapted to extreme environments. From bioluminescent creatures illuminating the dark with their eerie glow to giant squids that elude our cameras, the ocean's biodiversity is an untapped treasure trove waiting to be explored. Recent studies reveal that approximately 230,000 marine species have been formally described, but estimates suggest that there may be over 2 million undiscovered species lurking in the depths. This staggering number raises questions about the potential for new discoveries that could revolutionize our understanding of life itself. One remarkable example is the snailfish, a creature that has adapted to live at depths exceeding 8,000 meters in the Mariana Trench. Unlike its relatives, this fish has evolved a gelatinous body structure that allows it to withstand the crushing pressures of the deep sea. Its unique physiology could inspire breakthroughs in materials science and inform future technologies. The biodiversity of the ocean is not merely an academic interest, it has real-world applications. For instance, scientists have extracted substances from deep-sea organisms that could lead to advancements in medicine. Compounds found in the venom of certain deep-sea creatures have shown promise in treating conditions like cancer and chronic pain. Furthermore, the ocean's ecosystems play a vital role in regulating the global climate. The intricate relationships between marine species contribute to carbon cycling and nutrient distribution, influencing weather patterns worldwide. By preserving these ecosystems, we not only protect biodiversity but also safeguard our planet's climate stability. But what happens when we lose a species? The extinction of just a single organism can send shockwaves through the entire ecosystem. A poignant example can be found in the case of the Atlantic cod. Once abundant, overfishing led to a dramatic decline in cod populations, disrupting the marine food web and affecting countless other species reliant on them. This illustrates the fragile interconnectedness of marine life, where each species plays a crucial role in maintaining ecological balance. With climate change and human activities posing significant threats to marine biodiversity, it is imperative that we take action. Organizations and scientists worldwide are rallying to document and protect this unique life. For instance, the Census of Marine Life, launched in 2000, aimed to assess the diversity, distribution, and abundance of marine life and has already provided critical insights into our oceans. As we continue to explore the depths, we are not just uncovering treasures, we are also learning to appreciate the interconnected web of life that the oceans harbor. Each new discovery highlights the importance of conservation, as we realize that these dwelling places of wonder are as fragile as they are magnificent. As we edge closer to understanding the vast oceanic expanse, one question remains: what undiscovered marvels lie just beyond our reach? The vastness of the ocean plays a critical role in regulating our planet's climate, yet this relationship is becoming increasingly strained. As we delve deeper into the ocean's atmospheric interactions, one fact becomes alarmingly clear: the ocean absorbs a substantial portion of human-induced carbon dioxide emissions. In fact, it's estimated that the oceans have absorbed about 30% of the CO2 produced by human activities since the dawn of the Industrial Age. This process, while mitigating some of the impacts of climate change, comes at a cost. The increased CO2 levels lead to ocean acidification, impacting marine life from the smallest plankton to the largest whales. Coral reefs, often dubbed the rainforests of the sea, are particularly vulnerable. Acidification disrupts the ability of corals to build their calcium carbonate structures, leading to widespread bleaching and reef degradation. A shocking statistic reveals that approximately 50% of the world's coral reefs have been lost in the past 30 years due to these stressors. Coral reefs are vital ecosystems, supporting nearly 25% of all marine life, and their loss could lead to catastrophic consequences for marine biodiversity and the millions of people who depend on them for their livelihoods. The ocean is also a critical regulator of temperature and weather patterns. It stores and distributes heat around the globe, influencing atmospheric conditions and climate systems. Changes in sea surface temperatures can lead to extreme weather events, such as hurricanes and droughts, showcasing an intricate connection between the ocean and global climate. The implications of these changes are profound and far-reaching. The rise in sea level, driven by the melting of polar ice and thermal expansion due to warming waters, poses existential threats to coastal communities worldwide. In fact, it is estimated that sea levels could rise by over 3 feet by the end of this century if current trends continue, displacing millions of people. As we explore these compelling insights, we realize that protecting our oceans is not just an environmental issue, it's a matter of survival. International efforts, such as the Paris Agreement, aim to limit global warming and mitigate its effects on the ocean. However, without immediate and significant action, the results could be catastrophic. Marine protected areas are increasingly recognized as vital to conservation efforts. These designated regions help replenish fish stocks, restore ecosystems, and enhance the resilience of oceans against climate impacts. Success stories from around the world prove that collective action can foster revival in damaged marine habitats. The ocean's health is intricately woven into the fabric of our climate. As we face the challenges of our changing world, it is crucial to remember that the fate of the oceans lies in our hands. What choices will we make to ensure the delicate balance of this vital ecosystem is preserved for generations to come? Despite the profound beauty and complexity of the ocean, human beings continue to impose significant threats. From overfishing practices to pollution, the impact of anthropogenic activities is reshaping the deep oceans in alarming ways. In fact, a recent report from the United Nations found that around 34% of the world's fish stocks are overfished, leading to dramatic declines in marine populations. This unsustainable practice disrupts the delicate balance of marine ecosystems and threatens the future of many species. One of the most visible and horrifying impacts of human activity is ocean pollution. It's estimated that around 8 million tons of plastic waste enter the oceans every year, harming marine life and ecosystems. Plastic debris has been found at all ocean depths, even in the Mariana Trench. Ingested plastic can lead to devastating consequences for marine animals and even end up in the human food chain, raising concerns about the health implications for us all. Oil spills present another dire threat. The catastrophic Deepwater Horizon oil spill of 2010 released millions of barrels of oil into the Gulf of Mexico, causing extensive damage to marine ecosystems. The long-term effects are still being felt, as marine life struggles to recover from the contamination. This incident also underscored the need for stricter regulations on oil drilling and better response strategies to prevent future disasters. Moreover, deep-sea mining operations are emerging as a new frontier of exploitation. Mining for precious metals and minerals is expanding into previously untouched areas of the ocean, raising concerns about habitat destruction and biodiversity loss. The long-term ecological impacts of these activities remain uncertain, but the potential for irreversible damage evokes questions about the sustainability of our actions. As we navigate these pressing issues, it becomes clear that change is needed at every level, from individual behaviors to global policies. Initiatives like the Plastic Pollution Coalition are working to raise awareness and inspire action against plastic waste, while organizations such as Oceana are lobbying for sustainable fishing practices. The power of grassroots movements can drive significant change in environmental policy. However, many challenges remain. The ocean is vast and largely unexplored, making it difficult to enforce regulations and protect marine habitats. Innovative technological solutions, such as satellite monitoring and AI-driven analytics, are emerging to help track illegal fishing and monitor the health of oceans. As we confront these daunting challenges, one question stands out: can humanity prioritize the health of the oceans over short-term economic gains? The answer lies in our collective actions and commitment to sustainable practices that ensure the survival of our planet's most precious resources, including the deep oceans that continue to be our greatest mystery. As we stand at the brink of a new era in ocean exploration, the future holds immense promise and potential for understanding the deep seas. The technological advancements we've witnessed over the past few decades have revolutionized our ability to explore these uncharted waters. Autonomous underwater vehicles, or AUVs, are leading the charge in deep-sea exploration, allowing us to cover vast areas of ocean floor that were once inaccessible. These robotic explorers, equipped with advanced cameras and scientific instruments, are collecting data and images from the darkest corners of the ocean. In 2019, researchers using AUVs in the Southern Ocean discovered a new species of amphipod at depths of over 7,000 meters. Such discoveries exemplify how technology is unveiling the ocean's hidden treasures. Another groundbreaking innovation is the development of remotely operated vehicles, ROVs. These underwater robots can dive to extreme depths, equipped with manipulative arms for sample collection. ROVs played a crucial role in exploring the wreckage of the Titanic, revealing the ship's decay and the marine life that has made it their home. As we continue to improve the design and functionality of these vehicles, the potential for discovery will increase exponentially. Alongside technological advancements, renewed interest from both the public and private sectors is fueling a new wave of deep-sea exploration initiatives. Companies like Ocean Infinity are pioneering innovative exploration methods to map the ocean floor rapidly. Their ambitious projects aim to create high-resolution maps of the seabed, which could enhance our understanding of marine ecosystems and potential resource locations. Moreover, deep-sea exploration is becoming a collaborative effort. Global partnerships and initiatives like the UN Decade of Ocean Science for Sustainable Development aim to unite nations in understanding and protecting the ocean. The collective commitment to sharing knowledge and resources signifies a shift towards a more inclusive approach to ocean conservation. Yet, amidst this excitement lies a significant challenge: balancing exploration with conservation. As we push the boundaries of our understanding, we must tread carefully, ensuring that our actions do not harm the very ecosystems we seek to study. The responsibility lies with us to be mindful of the impacts of exploration and advocate for sustainable practices that protect fragile marine environments. As we look to the future of deep-sea exploration, one question looms large: what wonders await us in the unexplored depths of the oceans? The possibilities are endless, and the knowledge gained from these explorations has the potential not only to expand our understanding of marine science but also to influence critical decisions in policy and conservation efforts. As we reach the final chapter of our journey through the deep ocean, it becomes increasingly clear that the fate of the oceans lies in our hands. The discoveries and knowledge we've gained highlight not only the wonders of marine life but also the urgent need for collective stewardship. The ocean covers over 70% of our planet, influencing every aspect of life on Earth. Our collective responsibility extends beyond understanding; it is a call to action. As individuals, we can contribute to positive change through conscious choices and advocacy. Reducing plastic usage, supporting sustainable fisheries, and participating in cleanup efforts are just a few ways we can have a direct impact. The power of grassroots movements can inspire larger systemic changes that prioritize ocean health. Education plays a critical role in fostering a sense of connection to the ocean. Schools and organizations are integrating marine science into curricula, raising awareness among younger generations. By instilling a love for the ocean, we cultivate future stewards who will carry the torch in the fight for ocean conservation. Policy and legislation are crucial in safeguarding the oceans from exploitation. Governments must prioritize sustainable practices, enforce regulations against pollution, and invest in conservation initiatives. Organizations like the Marine Conservation Society advocate for robust marine protection, which is vital for restoring the health of ocean ecosystems. Furthermore, global collaboration is essential for addressing the challenges facing the oceans. The interconnected nature of the ocean means that our collective efforts must transcend national borders. Initiatives aimed at protecting migratory species and shared marine resources emphasize the need for unity in our conservation efforts. As we contemplate the vastness of the ocean and its mysteries, the question arises, what legacy do we want to leave for future generations? The choices we make today will significantly impact the health of the oceans and the planet as a whole. We have the knowledge, the technology, and the capacity to make a difference. All that remains is the will to act. In conclusion, the deep ocean is not merely a destination for exploration, it embodies the delicate balance of life and the health of our planet. As we face the myriad challenges that lie ahead, let us embrace our responsibility to protect and preserve the wonders of the deep, for ourselves and for generations yet to come. The ocean's mysteries beckon us not only to uncover them but also to ensure their survival, igniting a sense of hope as we look towards the future. As we venture deeper into the ocean's unexplored realms, we find ourselves at the Mariana Trench, the deepest part of the world's oceans. This trench, located in the western Pacific Ocean, reaches depths of approximately 36,000 feet, where sunlight can't penetrate. It is here that we discover an environment so alien that it challenges our understanding of life itself. The Mariana Trench has become a point of fascination not just because of its impressive depth, but also because of the strange creatures that inhabit its inky abyss. For instance, the giant amoeba, known as xenophyophore, can grow up to 10 inches wide and is a testament to the weird and wonderful adaptations that life has developed in such extreme conditions. Researchers who have ventured into the trench have uncovered other extraordinary inhabitants like the amphipod known as the deep-sea snailfish. This remarkable fish holds the record for the deepest known fish at a staggering depth of 8,300 meters, 27,000 feet. These discoveries leave scientists pondering how life can thrive in such crushing pressure and complete darkness. Furthermore, the trench is not only a reservoir of bizarre organisms but also holds clues about the history of our planet. Researchers have been exploring the idea that the trench plays a critical role in the Earth's geological processes. The subduction of tectonic plates in this region leads to significant geological activity, including earthquakes and volcanic eruptions. The interaction between the oceanic plates and the mantle below shapes our planet's surface and influences ocean currents and climate patterns. In recent years, technological advancements have allowed us to explore these depths more effectively. The use of remotely operated vehicles, ROVs, and manned submersibles have unveiled wonders that were previously beyond our reach. One of the most notable explorations was made by filmmaker James Cameron in 2012 when he descended to the bottom of the Mariana Trench in a custom-built submersible called the Deep-Sea Challenger. His journey provided invaluable video footage and samples that have helped illuminate the biological and ecological significance of this mysterious place. The Mariana Trench is not only a marvel of nature, it also presents a pressing question. As we venture into these depths, what responsibility do we hold for preserving such an extraordinary ecosystem? The potential for deep-sea mining and resource extraction raises ethical dilemmas that society must face as we strive to balance human advancement with conservation. As we conclude our exploration of the Mariana Trench, it becomes evident that while we have only scratched the surface of understanding this enigmatic environment, the secrets it holds may fundamentally change our perceptions of life on Earth. What other mysteries remain hidden in the shadows of the ocean depths? Imagine a world where life exists without sunlight, where organisms thrive in boiling water and toxic gases. This is the reality of hydrothermal vents, which have become one of the most compelling studies in deep-sea ecology. These underwater geysers, often found near tectonic plate boundaries, spew superheated, mineral-rich water into the dark ocean depths. They create unique ecosystems that are home to a plethora of bizarre species, many of which are not found anywhere else on the planet. The discovery of these vents was first made in 1977 during a deep-sea expedition by the research vessel Nor. Scientists were astonished to find thriving communities of life, including giant tube worms and chemosynthetic bacteria, which utilize the minerals from the Earth's crust as a source of energy. This discovery shifted our understanding of the potential for life and opened new doors to biological research. The tube worm, Riftia pachyptila, is one of the most iconic species associated with hydrothermal vents. These impressive creatures can grow up to 8 feet long and possess a unique adaptation. Their bodies contain a symbiotic relationship with bacteria that convert the chemicals spewing from the vents into food. This relationship exemplifies how life can adapt and flourish in extreme environments. Chemosynthesis, the process by which these vent communities derive energy, presents fascinating implications for the search for extraterrestrial life. Scientists speculate that similar life systems could exist on other celestial bodies, such as Jupiter's moon Europa or Saturn's moon Enceladus, where subsurface oceans may harbor hydrothermal vents. Research at hydrothermal vents has also contributed to our understanding of marine biodiversity and the evolution of life on Earth. Many species found in these ecosystems are unique to specific vent locations, leading scientists to study how these communities develop and evolve. By analyzing genetic data, researchers have discovered that some species share common ancestry, providing a glimpse into the evolutionary processes that occur in isolation. However, hydrothermal vent ecosystems face significant threats from human activities, particularly deep-sea mining and climate change. The delicate balance of life around these vents can be disrupted by disturbances such as pollution and habitat destruction. As our knowledge of hydrothermal vents expands, it is crucial to advocate for their protection and ensure that these ecosystems continue to thrive for generations to come. In exploring hydrothermal vents, we not only learn about the rich tapestry of life that exists in the shadows of the ocean but also gain insights into the resilience of life itself. What other extraordinary ecosystems lie undiscovered beneath the ocean surface that could redefine our understanding of life on Earth? Deep within the icy waters of the Southern Ocean, a remarkable fish has adapted to survive in one of the most extreme environments on Earth. This is the icefish, a creature that has evolved fascinating characteristics to thrive in frigid temperatures that would be lethal to most marine life. Icefish belong to the suborder Nototheniodidae and are primarily found in the Antarctic region. What sets these fish apart from their relatives is their blood, which contains an antifreeze glycoprotein that prevents ice crystals from forming. This adaptation allows them to swim in waters that can drop below freezing. In addition to their unique blood, icefish are one of the few vertebrates that lack hemoglobin in their blood. Instead, they possess a clear, colorless fluid that carries oxygen throughout their bodies. Although this makes them less efficient at oxygen transport, it allows them to thrive in oxygen-rich waters, making them a perfect example of evolutionary trade-offs. Remarkably, icefish play a vital role in the Antarctic ecosystem. They are a primary food source for various species like seals and penguins. Their presence in the food web is crucial for maintaining the delicate balance of marine life in these cold waters. However, icefish populations could be threatened by climate change and shifting ocean currents that affect their habitat. Scientists are increasingly studying the icefish to learn how they cope with extreme cold and low oxygen levels. The information gathered from these studies may lead to breakthroughs in biotechnology, medicine, and understanding how organisms adapt to climate change. For instance, understanding how their antifreeze proteins function could inspire new cryopreservation techniques used in medical procedures. In 2017, researchers successfully sequenced the entire genome of Icefish, revealing insights into the genetic adaptations that have allowed them to thrive in their extreme habitat. Such genetic research enables scientists to explore how species might adapt to rapidly changing conditions caused by global warming. As we learn more about the icefish, we not only explore the wonders of evolution but also gain insights into the convoluted relationship between climate and life. Will the icefish, this incredible survivor, withstand the challenges of a warming planet? The fate of the icefish may serve as a bellwether for the health of polar ecosystems, shedding light on what the future may hold for marine life in a changing world. Deep beneath the waves, hidden among the wreckage of forgotten vessels, lie the ancient shipwrecks that serve as time capsules of human history. These sites, often shrouded in mystery, tell stories of maritime trade, exploration, and even naval warfare that shaped the societies we know today. None of the most famous shipwrecks, the Titanic, sank on April 15, 1912, and remained undiscovered until 1985. Found 12,500 feet down in the North Atlantic, its discovery was made possible by advanced submersibles and remote-operated vehicles, ROVs. When explorers first laid eyes on the wreck, they were greeted with a ghostly sight, a monument to human ambition and a tragic reminder of our vulnerabilities. But the Titanic isn't the only ship that haunts the ocean depths. From the Spanish galleons laden with gold to World War II submarines, the ocean floor is littered with the remnants of our past. Each wreck holds artifacts that can teach us about the technological advancements of its time, the cultural artifacts lost with it, and sometimes even the personal stories of those aboard. For example, the discovery of the wreck of the USS Arizona at Pearl Harbor continues to educate us on the events of December 7, 1941, and its significant impact on American history. These shipwrecks are not just relics of history, they also serve critical ecological purposes. They can become artificial reefs, providing habitats for marine life. Scientists and conservationists are studying these wrecks to understand how marine ecosystems evolve and adapt. Moreover, many shipwrecks are sites of ongoing exploration. Technological advancements allow us to reach deeper and uncover more about our maritime heritage. For instance, the recent expedition to the wreck of the German U-boat, U-869, offered insights into submarine warfare, while also revealing how nature has reclaimed these vessels over decades. As we dive deeper into these historical sites, we uncover not just the remnants of ships, but the legacies and lessons they carry with them. How have these encounters with our maritime past changed our perspectives on history, conservation, and the future of exploration? Yet, the impact of human activity means that many of these wrecks are at risk from salvage operations, pollution, and climate change. As we learn more about what lies beneath the waves, we must also consider our roles in preserving these underwater time capsules for future generations. What will we choose to do with this knowledge and these treasures of the deep? And the exploration of deep-sea shipwrecks continues to unveil stories that not only enrich our understanding of history but also emphasize the importance of preserving the ocean's submerged artifacts and the ecosystems they support. For centuries, tales of gigantic sea creatures have danced around our imaginations. From the legendary kraken to the mysterious sea serpents, these myths have often been dismissed as folklore. But what if some of these stories hold a kernel of truth? In the deep ocean, life can take on forms we could barely dream of. The colossal squid, for instance, was once considered a mythical creature until one was finally captured on film in 2006. These creatures can grow up to 43 feet long and inhabit the deeper parts of the ocean, leading many to wonder what else might be lurking in those abyssal reaches. And another giant that truly exists is the whale shark, the largest fish in the ocean, measuring up to 40 feet. These gentle giants feast on tiny plankton, but they inhabit regions that are poorly understood. Scientists are working tirelessly to understand their migration patterns and breeding grounds. Recently, a study revealed that whale sharks travel thousands of miles across oceans, pushing the boundaries of what we know about their habitats and behaviors. And even more astonishing are the reports of giant jellyfish. The lion's mane jellyfish can span over 120 feet, a fearsome sight in the water. These gelatinous creatures are vital to exploring the food web, yet their blooms can be alarming. In 2015, a massive bloom threatened fisheries in the coast of Japan, reminding us how interconnected these ocean ecosystems are. And recent explorations have uncovered bizarre and previously unknown giant species, such as the giant isopod, which has been living in ocean depths for millions of years. This critter can measure over a foot long and has adapted to thrive in extreme conditions. The question remains, what other unexplored species lay hidden, awaiting discovery? And these encounters not only challenge our perceptions but also enhance our understanding of evolutionary biology. By studying the physical adaptations of these massive creatures, we gain insights into how life can thrive under extreme pressures, low temperatures, and darkness. Every discovery opens new questions. How have they evolved this way? As we navigate the labyrinth of deep-sea life, we must confront our relationship with these giants. Are we stewards of these creatures, or will our actions lead to their endangerment? The rise of climate change, ocean acidification, and overfishing means that understanding and protecting these massive beings is more critical than ever. We share our oceans with these behemoths. The myths and realities of colossal creatures inspire awe and respect. The more we explore, the more we realize that our planet's oceans are filled with extraordinary life, waiting for us to uncover. Just what's lurking in the deep remains an enduring mystery. Beyond the breathtaking life forms that inhabit the waters above, the ocean floor remains one of the last frontiers of scientific exploration. The geology beneath the waves holds secrets that could reshape our understanding of the Earth itself. And the ocean floor is not just a barren wasteland, it's a dynamic environment shaped by tectonic activity, volcanic eruptions, and sedimentation processes. For instance, the Mid-Atlantic Ridge, one of the most significant geological features on Earth, is where tectonic plates are separating, allowing magma to rise and create new oceanic crust. This process contributes to the planet's geological activity and provides crucial insights into plate tectonics and continental drift. And moreover, beneath the ocean surface lies a treasure trove of resources. Researchers are increasingly focused on deep-sea mining, aiming to extract materials like polymetallic nodules that contain valuable metals such as nickel, copper, and cobalt. However, this pursuit raises ethical questions. At what cost do we exploit these resources, and what impact does this have on fragile ecosystems? Reports indicate that mining could disrupt habitats that have thrived for millions of years, leading to irreversible damage. In 2020, the first commercial deep-sea mining project was launched in the waters of the Pacific Ocean, igniting debates about sustainable practices and environmental impacts. Many experts argue that we must prioritize conservation over exploitation, especially as we face a climate crisis. And additionally, research on hydrothermal vents has uncovered unique geological formations that support an entire ecosystem rich in biodiversity. These underwater geysers releases superheated water that is rich in minerals, creating a habitat for extraordinary organisms, including tube worms and giant clams. These vents not only serve as a refuge for unique life forms but are also vital for understanding the Earth's biogeochemical cycles. N through sediment core sampling, scientists have been able to reconstruct past climate conditions and sea level changes, revealing the intricate links between oceanic processes and global climate. This research is crucial for forecasting future changes in our climate system. N as we unlock the secrets of the ocean floor, we must grapple with the fact that our exploitation of these resources comes with grave consequences. The balance between pursuing knowledge and protecting the environment is delicate. How can we ensure that our quest for discovery does not lead to destruction? And the treasures hidden beneath the ocean remind us that the deep sea is not just a reservoir of resources but a vital component of the Earth's systems. Our fate is intertwined with the fate of the ocean, urging us to consider our collective responsibility to preserve this uncharted domain for generations to come. As sunlight fades into the depths of the ocean, a world pulses to life with glowing organisms, an enchanting display of bioluminescence. This phenomenon, where creatures produce light through chemical reactions, is not only mesmerizing but plays a crucial role in the survival of many species. From the tiniest plankton to the colossal jellyfish, the deep ocean is home to a myriad of bioluminescent beings that have adapted to their dark surroundings. Scientists estimate that around 80% of the deep sea is inhabited by creatures capable of bioluminescence, using it for various purposes such as attracting prey, deterring predators, and aiding in communication. One of the most fascinating examples is the lanternfish, the most abundant fish in the ocean, which emits light from photophores on its body. These small fish not only play a vital role in the marine food web but also exemplify the evolutionary wonders of bioluminescence. Recent research has explored how these organisms utilize light in the pitch-black depths, revealing insights about their habitats, life cycles, and interactions within the ecosystem. But the applications of bioluminescence extend beyond natural phenomena. Scientists are even looking into harnessing this biological marvel for innovative technologies, such as bioindicators for environmental monitoring or using bioluminescent proteins in medicine. As researchers dive deeper, the mysteries surrounding bioluminescence challenge our understanding of survival in extreme environments. What else do we have yet to discover about these glowing marvels? Stay tuned as we explore more about the intricate lives of those who illuminate the dark abyss. Beneath the ocean's surface lies a series of underwater volcanoes, some of which are among the most powerful and dynamic features on Earth. These geological wonders, often referred to as seamounts, play a crucial role in shaping marine ecosystems and influencing ocean currents. They emerge from tectonic plate activity, resulting in eruptions that create new landforms and seafloor habitat. The last few decades have seen scientists closely monitoring these underwater giants to unravel the secrets they hold. For instance, in 2018, the eruption of the Cavachi volcano in the Solomon Islands was observed by researchers using underwater drones. This event provided a unique window into submarine volcanic activity and its immediate effects on surrounding marine life. These volcanoes also form hotspots of biodiversity, attracting various marine species looking for food and shelter. Coral reefs flourish around these structures, creating rich ecosystems that are home to species like clownfish and anemones. Furthermore, the heat and minerals expelled during eruptions drive chemical reactions that sustain unique microbial communities, paving the way for life in otherwise inhospitable environments. Scientists have found that these ecosystems can serve as analogues for understanding similar processes on other planets, like Jupiter's moon Europa, which may harbor hidden oceans beneath its icy crust. As we delve into these subaquatic realms, what new geological wonders and hidden life forms will we uncover? The wonders of submarine volcanoes are just beginning to surface. The deep sea, often referred to as the ocean's last frontier, hosts some of the most complex and poorly understood ecosystems on the planet. Each ecosystem is a delicate web of life, intricately connected, from the smallest microorganisms to the largest predators. Recent scientific expeditions have revealed startling discoveries about these ecological communities. One such expedition was the 2012 deep-sea exploration conducted by the Ocean Exploration Trust aboard the research vessel Nautilus. Equipped with remotely operated vehicles, scientists uncovered previously unknown species living in the darkness, including vibrant corals, unusual sharks, and even new types of octopuses. These deep-sea ecosystems are essential for global biodiversity and play a significant role in regulating Earth's climate. For instance, deep-sea coral reefs act as vital habitats for various fish species, while also providing important carbon storage capabilities. Moreover, the impact of human activities such as deep-sea mining and pollution poses a significant threat to these fragile ecosystems. Understanding the interconnectedness of life in the deep sea is critical in advocating for conservation efforts. With each exploration, we inch closer to comprehending the full extent of life in the abyss. What revelations await in the next deep-sea missions? The secrets of the ocean depths are yet to be fully unlocked. As we explore deeper into the ocean, we not only uncover hidden life forms but also the mysterious sounds that fill these dark waters. The ocean is an acoustic environment that is both vibrant and complex. It is a place where sounds travel further and faster than they do in air. Recent studies have shown that marine animals use sound for communication, navigation, and hunting. From the haunting songs of the humpback whale to the sharp clicks of dolphins, these soundscapes are a crucial part of ocean life. One fascinating discovery happened in 1997, when scientists detected a mysterious sound known as the bloop. This ultra-low frequency sound was heard over thousands of miles and has sparked theories ranging from icebergs breaking to unknown sea creatures. The truth behind the bloop remains largely unresolved, adding to the mystique of the ocean's depths. In addition to natural sounds, human-made noise pollution poses a significant threat to marine life. Ships, sonar operations, and underwater construction disrupt the acoustic environment. A study published by the National Oceanic and Atmospheric Administration, NOAA, estimated that ambient noise levels have increased significantly due to human activity. This rise in noise not only affects communication among marine animals but also leads to disorientation and strandings. Researchers are now implementing quieter technologies and regulations for ship operations to mitigate this impact. The role of sound in the ocean goes beyond just communication, it is also integral to ecosystems. For example, fish use sound to assess their environment and locate mates. A study from the University of Exeter found that fish exposed to predictable soundscapes exhibit more natural behaviors, highlighting how important sound is for their well-being. Furthermore, the installation of underwater microphones, or hydrophones, has opened a new window into studying these deep-sea communities. Scientists now have the capability to record and analyze these unique underwater symphonies, leading to discoveries that were previously unimaginable. As we delve into the future of ocean acoustics, the concern remains about the impact of climate change. Warmer water temperatures change sound propagation, potentially disrupting marine life even further. Researchers are tirelessly working to understand these changes and find solutions to preserve the delicate acoustic environment of our oceans. The next chapter of ocean exploration is not just about what lies beneath the waves, but also about listening closely to the stories the ocean has to tell. Will we be able to learn from the symphony of the deep and protect these essential communication channels? The answer lies in our capacity to adapt and innovate. As we end this chapter, the question remains, what other auditory wonders await us in the vast unknown? As interest in the ocean's depths grows, so too does the push for deep-sea mining. This controversial area of exploration raises profound questions. Are we tapping into the planet's resources responsibly, or are we recklessly ravaging a fragile ecosystem? Advocates argue that the ocean floor is rich in valuable minerals like cobalt, nickel, and rare earth elements that are essential for modern technology, especially in the age of renewables. The International Seabed Authority, established under the United Nations Convention on the Law of the Sea, issues permits for exploration and contracts for mining rights. However, the destructive impact of such activities is alarming.